in my previous video, I calculated the expected return of a portfolio with two assets, but it was a very simplified version of it. So we're going to factor in for standard deviation of the return. It means that we're factoring in for the individual volatilities of the asset, the weight of each asset in the portfolio, and the correlation between the assets. So in the previous example, we used this equation, ERP equals the proportionality symbol ERA plus 1 minus dot ERB. I'm not going to go over what all of this represents because I did that in another video. I'm going to link that in the description. But I'm going to just plug in the values so that we can begin moving on. So let's say my return of the first asset is 10%, and the expected return of the asset B is going to be 6%, and I'm going to put 70% into asset A and 30% into asset B. It means that we're going to have 0.7 and 1 is going to be 0.3. We can now plug this into here. So the expected return is going to be 0.7 times 0.1. I've converted 10% into a decimal, then plus 0.3 times 0.06. So we're now going to get 8.8%. You can get 0.088 times that by 100, and you're going to get 8.8%. So that's the expected return. But now we're going to focus on calculating how we can factor in for standard deviation of the return. So firstly, we're going to use the symbol sigma for the sigma P, which is the portfolio's standard deviation. We're going to use sigma A and sigma B to be the standard deviation. So I'm going to just say the standard deviation of assets A or B. So if it's sigma A, sigma B, B. Then you're going to have rho AB, which is the correlation coefficient between asset A and B. We've gone over the proportionality symbol, or as I would like to call it, reverse fish, which is the weight of asset A. So how much have you put into asset A over versus asset B? So weight of asset A, and then you're going to have 1 minus reverse fish, which is the weight of asset B. Now let's start building the equation. So you're going to get sigma P equals the reverse fish squared times the standard deviation of asset A squared plus 1 minus alpha, not alpha, a proportionality symbol, reverse fish squared dot sigma B squared plus, I'm going to just start underneath now, 2 times reverse fish 1 minus reverse fish times sigma A sigma B times rho AB, and all of this is square rooted. It's quite something. So let's now plug everything in. So we're going to now say that, let's say that sigma A is 0.15, sigma B is 0.08, and let's do row AB equals 0.2, so that's a low correlation between assets. And let's start plugging away. So you're going to get 0.7 squared, 0.15 squared, plus 0.3 squared, times 0.08 squared, plus 2 times 0.07, times 0.3 times 0.15 times 0.08 times 0.2. So I've literally just put each of these values and I followed it along. So this is quite a complex one. 2 times obviously the weight times the weight of the other asset times this times this times this. So there should probably be a multiplication there as well. So you can now simplify. Oh, and then obviously that's all going to be square rooted, isn't it? So there we go. I'm going to just quickly go through this instead of breaking it all down. But you're going to get 0.129 times that by 100, and you're going to get 12.9%. So what does any of this mean? So the expected portfolio return is 8.8%. The portfolio risk is 12.9%. So by combining two assets with two different risk levels, it potentially achieves a better risk return trade-off, especially if the correlations are low. I bet that was really worth it. Cool.